Hi kids, it is April 30th and I hope everyone is doing well today. The weather here has been beautiful. I hope you've been able to get outside and enjoy some of it. Today we're working on Unit 8, Lesson 12, and these are more real world type problems for you to consider as you're working with length, area, and volume. I included a picture here for you to refer to in terms of length, and length is something that is one-dimensional and it tells how wide something is or how long something is. One example might be how tall are you? That would be an example of length. The second one is area, and it tells you how much surface a figure covers. And a real world application for that would be if you were going to put flooring in your house, such as like carpet or wood floor, you would need to figure out the area for the floor to see how much of it needs to be purchased and laid. The last one is volume, and we've been working a lot with that. Volume tells how much space an object occupies, and an example of that would be a swim pool. So how much water is in a swimming pool. That would be a real life application that you would be able to reference. Another thing to keep in mind is when you are using length, which tells how wide or tall or long something is, it's a one-dimensional measurement, and you can see that like things like height, it would just be one dimension. You're only considering the one dimension. Area is two-dimensional, and that's, remember when we're solving for area equals length times width. It's two-dimensional and it's measured in square units. And volume is three-dimensional, where it's length times width times height, and it's measured in cubic units. As we start on the homework side of 8:12, it's again kind of trying to think about the world around you and what you would use to measure the object in the question. And number one says the amount of space inside a moving van. And when we think of a moving van, I like to think of like the UPS man, the delivery truck, because you can think of the space inside of that. And this is a situation where you would want to be thinking in terms of volume. How many packages could be transported in the back of that van? So number one, we would be thinking in terms of volume. Number two says the number of tiles needed to cover a bathroom floor. Well, this is something that's a two-dimensional shape, okay? So you're only considering the length times the width, and that's area. So a two-dimensional shape. And that's area. Sorry, it's hard to write with this little pen. When we look at number three, it says the distance from a porch to a tree, and that's a one-dimensional, a straight line. So you're measuring just the length of something, the distance from the porch to a tree, and that would be length. The amount of water that a tank holds is similar to our real life application when we were talking about the amount of water in a swimming pool, and that would be volume. And then if you look at number five, it says the height of a flagpole. Again, that's one-dimensional, straight up. The length of a flag, or the height of a flagpole would be length. Number 6 says a box is 5 inches long, 4 inches wide, and 1 inch deep. How much space is inside the box? And so when we talk about how much space an object occupies, if you remember back here on our chart, you can see here how much space an object occupies is volume. And so we're going to use our volume formula. V equals L times W times H, which is volume is equal to length times width times height. So we have volume is equal to 5 times 4 times 1. So volume is equal to 5 times 4 is 20 times 1, and it's 20. And you have to go back, and we have inches, and remember when we're working volume it's cubic, so CU, cubic, and then inches. So number 6 is 20 cubic inches. Number 7, Apani built a toy chest for her niece. It has a volume of 12 cubic feet. The chest is 3 feet long and 2 feet wide. How deep is it? Well, we have our volume formula up here, and this is one of those situations where we're missing not the volume, but one of the other pieces, so we have to solve for that. So we take our volume, which is 12, and it is equal to the chest dimensions, which it's 3 feet long, times 2 feet wide, times an unknown number. We don't know how deep that chest is. So we take 3 times 2 is 6, okay? And what we have there is 12 is equal to 6 times what number? And in order to solve for that, we divide both sides by 6, and 12 divided by 6 is equal to 2. So your answer is going to be 2 feet deep. For number 8, the rug in Alan's room has an area of 18 square feet. He is planning to buy another rug that is twice as long and twice as wide. What is the area of the new rug? I like to start this off by remembering that I have an equation for area, and remember that area is equal to length times width, because it's a two-dimensional object. Area is two-dimensional. So once I have that formula, I know that I have the area already, and the area is 18 square feet. And so I have the area, but I don't have those two sides. So how am I going to know how to double them? Well, the way that I think about this is I think about factors of 18. I think about 18 and 1, because 18 times 1 is equal to 18. I think about 9 and 2, because 9 times 2 is equal to 18. I think about 6 and 3. 6 times 3 is equal to 18. So the 1 and the 18, the 2 and the 9, and the 3 and the 6 are all factors of 18, and any of them would work. And let me show you what you can do there. You can see that if you doubled these, they're all going to equal 72 in terms of the area. So if I took my 1 here and I doubled it, because I need to double the length, and then I took my 18 and I doubled the width, it's 36, and 36 times 2 is equal to 72. You can look at the next one, and it's going to be the same thing. If I double my 2 here, it becomes a 4. If I double my 9, it becomes an 18, and 18 times 4 is equal to 72. Same thing down here. If I double my 3, it becomes a 6. I double my 6, it becomes a 12, and 12 times 6 is equal to 72. So I know that the area of the new rug is going to be 72 square, which is SQ, and then feet, square feet. We're going to move to number 9. It says each drawer in Monique's nightstand has a volume of 6 cubic decimeters. Each drawer in her dresser is twice as long, twice as wide, and twice as deep. What is the volume of one of Monique's dresser drawers? Well, we have volume is equal to length times width times height. In this problem, it gives us the volume of 6, but it doesn't give us any of the dimensions. But we know that we have to find 3 numbers that multiply together to equal 6. And when I think of that, I can think of 3 times 2 times 1. 3 times 2 is 6, and 6 times 1 is 6. And then I'm going to go back and I'm going to read my question again. And what it asks, it says, each drawer in a dresser is twice as long, twice as wide, and twice as deep. So I need to take each of those factors there, and I need to double it. 3 2 times is 6. 2 times is 4. And 1 2 times is 2. So then I have 6 times 4, which is equal to 24, times 2, which is equal to 48. And my answer is going to be 48 cubic decimeters. And you can write CU and then DECIMETERS, decimeters. For number 10, I'm going to create another page here so that I can blow it up a little bit. It says Fong and Daphne built these structures. Who used more cubes? How many more? Well, here you're figuring out cubic units. So how do we find the cubic units? Remember what we did to find cubic units. We took the number of cubic units high, and here you can see there's 3. We took the number of cubic units across, and here you have 6. and then the number of cubic units deep, which is 5. And then we multiply 3 times 6 times 5. 6 times 3 is 18. 18 times 5 is 90, and that's cubic units for Fong. And then we need to do the same thing for Daphne to figure out what she has. And here we have her height. I'm going to erase this. We have her height of 4, and we have her width of 5, and we have a depth 1, 2, 3, 4 of 4, and we're going to do the same thing. 4 times 5 times 4 is 20 times 4, which is equal to 80 cubic units for Daphne. It says who used more cubes and how many more? Well, we can see here that if we look at what we just solved, we can see that Fong used more because he had 90, and Daphne had 80, and so Fong used more cubes. But there's also a second part to this question, and it asks how many more. And in order to figure out how many more, we need to take how many Daphne had and subtract that from Fong's total, and that's just 90 minus 80, which is equal to 10. So 10 cubic units more. As we move to the remembering side, you're going to see that you're multiplying decimals on numbers 1 through 6. And the biggest thing to remember when multiplying decimals is you ignore the decimal while you're completing your multiplication, and then you count how many numbers in the original problem are behind the decimal and move it over. And I'm going to do number 3 with you, and we'll solve number 3 together, and I'll show you exactly what I'm talking about. So number 3, we have 3 and 3/10 times 0.78, or times 78 hundredths. And I'm going to multiply just like I do in any other multiplication. Okay, 8 times 3 is equal to 24. Put down my 4, carry my 2. 8 times 3 is 24, plus 2 more is 26. Carry my 2. Then I'm going to put down my placeholder. 7 times 3 is 21. Carry my 2. 7 times 3 is 21, plus 2 more is 23. And then I'm going to just add them up. 4 plus nothing is 4. 6 plus 1 is 7. 2 plus 3 is 5. And 2 plus nothing is 2. And now I have to go back and figure out, where does my decimal go? Well, if I look in my original problem, I can see I have 1, 2, and 3 numbers that are to the right of the decimal. So I need to start after my last number, which is my 4, and I need to move in 1, 2, 3 spaces. So my answer is going to be 2 and 574 thousandths. You can see down here on numbers 7 through 12, we're working with volume again, and I put our little equation up here, our formula for volume, so that you can see it, and I'll just move it right up here. Volume is equal to length times width times height, and you are going to do the same thing that we did in our last lesson on Tuesday, and you're going to do it again here and figure out what is missing. Volume, length, or width, or height, any of the above. Actually, just volume, length, and width. The height isn't missing in any of these problems. And I'm going to solve one with you, and I think I'm going to choose number 8 this time instead of just solving for volume, which we do often. I think we'll look at number 8, and in number 8 you can see here that the length is what's missing. So volume in this problem is 200. So 200 is equal to, well, the length is missing, so I just put a little question mark there, times the width, which is 5, times the height, which is 5. And now all I'm going to do is combine my like terms. 5 times 5 is equal to 25. Okay, I bring down my sign here. and then I bring down my question mark because I still don't know what the length is equal to 200. So 200 is equal to something times 25. All I have to do now is divide by 25 on both sides to figure out what my answer is going to be, and this will give me my length. 200 divided by 25 is equal to 8. So the length here is 8 yards, and yards is YD, 8 yards. Work through the rest of those problems and let me know if you have any issues. You can always send me a message in Teams or send me an email if you're struggling. But the review is, I think, pretty easy practice today. So I hope you all have a wonderful day and take care of yourselves. I miss you all.